Welcome to the prototype pattern, one of the original gang of 4 creational patterns. By the end of this video, you will understand exactly when and why cloning an existing object is smarter than constructing a brand new one, and you will be able to write the pattern yourself in TypeScript. Imagine you have an object that took significant work to build. It loaded configuration from a database, parsed a large file, or ran through an expensive initialization sequence. Now you need a second object that is almost identical to the first, with just one field changed. Reconstructing it from scratch wastes all that effort, and if you do not know the concrete type at compile time, calling a constructor directly is not even possible. That is the pain this pattern addresses. Think about a photocopier in an office. When a colleague needs a contract that is almost identical to one you already filled out, nobody retypes the whole document. You copy it and change just the fields that differ. The original document is your prototype. The copy is your new object. That simple idea, duplicate a known good instance rather than construct from zero, is the entire heart of this pattern. The formal intent, straight from the gang of 4, is to specify the kinds of objects to create using a prototypical instance and create new objects by copying that prototype. There are 3 core participants. The prototype is an interface or abstract class that declares a clone method. ConcretePrototype classes implement that method to return a copy of themselves. The client simply calls clone on whichever prototype it holds, without knowing or caring about the concrete type. An optional prototype registry can act as a catalog of pre-built prototypes keyed by name. Let us walk through the code. First, we declare a generic prototype interface with a single method, clone, that returns a value of type T. Next, enemy config implements that interface. Its constructor takes a name, a health number, and an abilities array. The clone method creates a brand new enemy config, passing the same name and health values, and spreading the abilities array with the spread operator, that creates a new array with the same elements, so the clone owns its own copy. In the client section, we build one base ORC with expensive to construct state. To get an elite variant, we call base ORC.clone, then change only the fields that differ. Because clone made a separate copy of the abilities array, pushing rage onto the clone leaves base ORC untouched. That is the critical difference between a shallow and a deep copy, which we will discuss next. When clone is called, the concrete prototype is responsible for deciding how deep the copy goes. A shallow copy duplicates primitive fields and copies references to nested objects, meaning the original and the clone share those inner objects. A mutation in one affects the other. A deep copy recursively duplicates every nested structure, giving the clone full independence. The pattern's big win is decoupling. The client never imports or instantiates a concrete class, it only speaks to the prototype interface. The trade-off is that every class in your hierarchy must implement clone correctly, and keep it up to date as new fields are added. Reach for prototype when construction is genuinely expensive, network or disk I/O, complex initialization, or when you do not know the concrete type at compile time and need to produce variants at runtime. It also shines when you want many similar objects without exploding your subclass tree. Skip it when objects are trivially cheap to build. The added clone method is pure overhead. Also be cautious when your object graph is deeply nested or contains circular references, because writing and maintaining a correct deep copy becomes a significant burden that may outweigh the benefit. To summarize, prototype lets you stamp out new objects from a known good instance via clone method, which is faster than reconstruction and works even when you do not know the concrete type at compile time. The most important implementation decision is shallow versus deep copy. Get it wrong, and your clone silently share state with the original. Use this pattern when construction cost or runtime, only type knowledge justifies it, and favor simpler approaches when your objects are cheap to build.